Hello students, welcome to my channel. In this video, we will study about the ESR spectra of the species that is containing two or more than two unpaired electron. In the previous video, we studied that ESR spectra of the species that is containing one unpaired electron. Like we studied the ESR spectra of hydrogen, and also we studied about the ESR spectra of deuterium. Nuclei, right? So in this class, we will be studying about the ESR spectra of species that is containing two or more than two unpaired electrons. Okay, to explain this concept, I'll be taking an example of naphthalene. Okay, naphthalene. So let me write the structure of naphthalene first. This is the structure of naphthalene. Okay, and if you irradiate this naphthalene, irradiation, okay, or whenever you give the radiation, what happens is that one of the bond that is present in a naphthalene cleaves homolytically to give the biradical. Okay, whenever you irradiate the naphthalene by radiation, what happens? Any of the bonds, okay, let me take this one, that will cleave homolytically to give the biradical, or it can also be called as diradical. Okay, I get a radical here, and the rest of the bond will be remain as such. Okay, this is naphthalene diradical, or it can also be called as naphthalene biradical. Okay, this is naphthalene di or biradical. Okay, while this is a naphthalene. Okay, now in this naphthalene biradical system, there are two unpaired electrons, right? These two unpaired electrons will have the S value, that is spin value. Okay, let me take the spin value for the one of the electron as half, and for the second electron, let me take it as 1 by 2. Okay, there are two unpaired electron. For this, S1 is half, and while for this second electron, the S2 is a half. Therefore, what will be the effective spin? Yes, capital S means what? It is an effective spin or total spin of that molecule. That will be sum of S1 and S2. Okay, that is half plus half, that we will get 1, right? So effective spin of that molecule will be 1. Okay, and later that we have to write ms value. So what is ms value? It is a quantum number that is related to the spin, right? Spin angular momentum quantum number. Okay, what is ms? Ms is nothing but spin angular momentum quantum number. We know that ms value is given by minus s to plus s. Right, so we know S value is 1, so the MS value will be from minus 1 to plus 1. Okay, now how many values are there? We have 3 values. Okay, how to know how many MS value are there? We have formula, that is MS is equal to 2S plus 1, and S value is 1 for this molecule. So if you solve this one, you will get a 3 MS values, right? So what will be the 3 MS value? That will be minus 1, 0, plus 1. Okay, there are 3 ms values for the naphthalene biradical system. Okay, let me write the energy level diagram that is very similar to the energy level that we have drawn earlier for hydrogen and deuterium molecule. Now, initially there are 3 ms value. Okay, now I am writing the energy level diagram. Energy level diagram. Initially, there are 3 ms value, plus or minus 1 and 0. Okay, initially in the absence of magnetic field, all the 3 ms levels are having the same energy. Okay, they are degenerate. Now if you apply the magnetic field, okay, H not equal to 0 means it is in the presence of magnetic field. So what happens? We already studied that in the presence of magnetic field, this ms level will split, right? It will split into 3 levels now. Okay, it will split like this. Okay, initially it was degenerate in the absence of magnetic field, but once you apply the magnetic field, all the 3 levels will have different energy now. Okay, so this will be our ms is equal to negative 1, this is ms is equal to 0, while this is ms is equal to plus 1. Okay, and we also know the energy for the ms levels, right? So what is the energy of ms level? We know it is given by this particular expression, ms is equal to g beta h. Okay, this is the expression for energy of ms levels. Okay, it is given by what? Ms g beta h. Now for this level, that is ms is equal to -1 level, ms is equal to -1, what will be the energy? Energy will be minus right, ms is -1, so simply minus g beta h. So this will be the energy of this particular level, that is minus g beta h. And for this level, what will be the energy? ms is 0 for this particular level, so 0 into anything becomes 0, so energy is also a 0 for this particular level. And while for this level, what will be our energy? Energy will be positive 1, ms is positive 1, no, so energy will be plus g beta h. Correct. So this is the expression. By using this particular expression, we arrived at these expressions, right? Now we know the selection rule for the ESR, in the ESR spectrum, we know the transition, that is, we know the spin selection rule, right? Spin selection rule that is present in this ESR spectroscopy, that is delta ms is equal to plus or minus 1, and we also have an delta mi is 0, right? So this is the selection rule that we have already studied for the ESR transitions, right? Delta ms is equal to plus or minus 1 and delta mi equal to 0. So by using this particular thing, we can say that there are two transitions is occurring, right? So one is this transition, okay, for which we get delta ms is -1, and for this we will get delta ms +1, right? The difference between this and this, and difference between this and this will be the plus or minus 1. So we can see there are two transitions are occurring. I call it as a first transition, and let me call this particular transition as second. Okay. Now, what is the energy that is required for this particular transition? Let me call it as delta E1. Okay, let me take another paper. Delta E1. Okay, the delta E1 means what? It is the energy required for this particular transition. Okay, from here to here, what is the energy required? No, that is delta E1. Similarly, I call delta E2 for this one. Okay, for this particular transition, I call it as delta E2. Now, what is delta E1? Delta E1 is what? It is this minus this. So you get what? 0 minus g beta h. Correct? This minus this. So you will get simply g beta h, because minus positive, so simply g beta h. Similarly, what is the expression for the energy? Delta E2, that is this energy for this level minus energy for this level. We know energy for this particular level is g beta h, minus energy for this is 0. It is given by what? Simply g beta h. Okay. As the energy for both the transition is same, we expect only one line, okay, one line in the ESR spectra. Okay, we should get only one signal in the ESR spectra. Why? Because energy for both the transition being same, we should get only a one line in the ESR spectra. Okay, that is what our prediction. Okay, this is theoretically we predict that there should be only one line in ESR spectra, because energy for both the transitions are same. We are expecting this thing, but experimentally, what is observed experimentally? We get two lines or two signals in the spectra. Okay, this thing is theoretically. Okay, theoretically we expect that there should be only one line in the ESR spectra, as the energy is the same. No, we should get only one line, but it is proved experimentally that in the ESR spectra we get two lines for the naphthalene biradical system. Okay, now to explain this particular concept, that is in order to explain how you get to two lines in a ESR spectra experimentally, we have to change some theoretical concept a little bit. Okay, we have to change theoretical concept. Okay, we should change the theoretical concept. That means whatever we have written, no, energy level diagram in this case, that is here, that must be wrong. Okay, so this is wrong. Means if it is right, we cannot explain why experimentally we are getting two lines. Okay, in order to explain how two lines are observed in ESR spectrum, there must be a change in the energy level diagram for the naphthalene biradical. Or in general, what I can say is that this particular energy level diagram, or whatever we have written as energy level diagram earlier in the videos, that is applicable only for the system that is containing only one unpaired electron. Okay, if the system is having more than one unpaired electron, then energy level diagram must be different. Okay, that concept is explained by this one, that is zero field splitting. Okay, zero field splitting. Okay, here the new concept comes, that is zero field splitting, in order to explain the experimentally why you are getting two lines. Now that can be explained by the new concept called as zero field splitting. Okay, now we will see what is the meaning of zero field splitting. According to this particular concept, okay, let me write the energy level diagram first. Okay, this is in the absence of magnetic field. Okay, that is ms is equal to plus or minus 1 and 0. Okay, all the three levels are degenerate in the absence of magnetic field. Okay, according to zero field splitting, what happens is that in the absence of magnetic field, this 3 ms level will split. Okay, there will be a what? Splitting of ms level will occur even in the absence of magnetic field, and that is what we call the zero field splitting. So according to this particular concept, and these three level will split like this. Like this. Okay, the 3 ms level, initially it was degenerate, and even in the absence of magnetic field, what was observed? We observe that, or it is also a theoretical concept in order to explain experimental behavior. Okay, the 3 ms level split like this. Okay, this is ms is equal to 0, while this is ms is equal to plus or minus 1. Okay, here these two levels are degenerate. Okay, ms is equal to plus or minus 1, this is degenerate, while this is not degenerate. Okay, this is called as zero field splitting. Okay, what is zero field splitting? The splitting of ms level occurs even before an external magnetic field is applied. Okay, that is what we call zero field splitting. Okay, zero field means no magnetic field is applied, but still there is a splitting of ms level, and that is why it is called as what? Zero field splitting. Now imagine you are applying a magnetic field now. Okay, you are applying a magnetic field where H not equal to 0. Okay, that is in presence of magnetic field. Okay, while these two are in the absence of magnetic field only. Okay, now you are applying a magnetic field. What is observed is that the level ms equal to 0 retains its position. Okay, this is ms is equal to 0, that will retain its position. But initially here ms equal to plus or minus 1 was a degenerate. Now what happened is that there will be a splitting of these two level take place. How? We will see that it is like something like this. Okay, like this. Okay, here this one is ms is equal to minus 1, while this is ms is equal to plus 1. Okay, these two, initially it was a degenerate. What happens if you apply the magnetic field? That will splits. Okay, while this will retain its position as such even in the presence of magnetic field, while this level will split like this. Now you can observe that there are two different transition of different energies. Okay, the energy required for this particular transition is less, while the energy required for this particular transition is more. Okay, as a result we can expect two lines. As the energy for both the transition is different, we expect two transition. Okay, this is what zero phase splitting is. Okay, while this concept or the energy level here requires, if you look into this energy level diagram, the energy required for this transition and this transition is same, right? As a result we expect only one line, but experimentally two lines are observed for the system with the two unpaired electron. to explain that, we have zero field splitting. Okay, according to zero field splitting, what happens? There will be a splitting of the ms level in the absence of magnetic field. Okay, this thing that is called as zero field splitting. Now if you apply magnetic field to this particular system, what happens? It will split like this. Okay, we can see the two transition of two different energy, and hence two transition or two lines or two signals can be observed in the ESR spectra. Okay, so what are the two transition here? ms is equal to -1 to ms is equal to 0, and ms is equal to 0 to ms is equal to what, +1. Okay, these are the two transition that you can observe in the ESR spectra. Now this is the system with the two unpaired electron, right? We consider this one naphthalene biradical. This is a system with the two unpaired electron, and we observed how many lines in a ESR spectra? 2 lines. Okay, if you have the species with the 3 unpaired electron, for example, okay, if you have a species with the 3 unpaired electron, then in the ESR spectra of that particular species will contain 3 lines. Okay, if you have 2 unpaired electron species, then it would have 2 lines. If you have species with 3 unpaired electron, then you will get 3 lines. Okay, in general, what you can say is that if you have the system that is containing n unpaired electron, okay, if you have the system that is having n unpaired electron, then the spectra of that particular species will have n lines in that or n signal in that particular spectra. Okay, this is in general. Okay, now if you consider example of Mn2 plus, okay, this is a transition metal ion and it contains 5 unpaired electron, right? Mn means what? It is having 25, atomic number is 25. So if you write the electronic configuration, what you get? Argon 3d 4s, right? This is 18, 18, 19, 20, 25, right? This is a electronic configuration of Mn. Now what is the electronic configuration of Mn2 plus? You get argon 3d5, correct, right? So in this we have 5 unpaired electron. Okay, there are 5 unpaired electron. So in the ESR spectra we should expect 5 lines or 5 signals are observed for this particular system. So okay, Mn2 plus. Okay, now we have a new transition here. Okay, there is a possibility of another transition, that is there is a possibility of breakdown of selection rule here. Okay, there is a possibility of what? Breakdown of selection rule. Okay, what is the breakdown of selection rule means? Initially we had a selection rule that is delta ms is equal to ±1, right? This is the selection rule for the ESR spectrum. Now because of the zero field splitting, okay, we can also expect another transition, that is delta ms is equal to ±2. Okay, so that is why I called it as there is a breakdown of selection rule in this case. Okay, because because of this particular splitting, we can also observe this particular transition, that is delta ms is equal to ±2 along with this one. Okay, so if you look into here, along with these two transitions, okay, there is one more transition possible, that is related to this one, delta ms is equal to ±2. So that is this one. Okay, this one, that is ms is equal to -1 to ms is equal to +1. So we expect sometime, okay, there is a condition. Okay, sometimes we get 3 lines. Okay, 3 lines. Okay, that depends upon the distance. Okay, that depends upon what? Dipolar shift. Okay, the gap is there now between these two levels, that is called as d, that is dipolar shift. Okay, depending upon this, whether it is smaller or bigger, okay, depending upon this, we can sometime expect the 3 lines. Okay, that means if the d is smaller, if the d is smaller. Okay, what is d? D is the dipolar shift, that is difference between this degenerate level and this ms is equal to 0 level. Okay, if the d value is smaller, okay, if the gap between them is smaller, then you can expect 3 lines. But if the d is larger, for example, okay, if the d is larger, then you cannot expect this particular transition. Okay, this selection rule is only for this one. Okay, if the d is smaller, then you can expect there is a transition that is corresponding to delta ms is equal to plus or minus 2. Okay, while if the d is larger, then only 2 lines, then only 2 signals is observed, okay, in the ESR spectra. Okay, now we will see the system that is containing 3 unpaired electrons. System with 3 unpaired electron. Okay, so far we have seen the system with the 2 unpaired electron, right? So if the system is having 3 unpaired electron, what will be the S value? For first 1 electron, it is 1 by 2, correct? There are 3 unpaired electrons, so S1 is half, S2 is also 1 by 2, and S3 is also 1 by 2. So what will be the effective S value? S value is sum of all the 3, S1 plus S2 plus S3. So I can write 1 by 2, 1 by 2, and 1 by 2, you'll get 3 by 2. Okay, this is the effective spin of the system with the 3 unpaired electron. So if S is equal to 3 by 2, what will be the MS value? MS value is, we know it is from minus ES to plus ES. So we get minus 3 by 2 to plus 3 by 2. So what will be the value in between these two values? We have minus 3 by 2, minus 1 by 2, plus 1 by 2, and plus 3 by 2. Okay, there are 4 values. Okay, how to know that how many ms values are there? I already gave this particular equation, correct? So we know ms is equal to 2s plus 1. Okay, 2s means what? S is 3 by 2, 3 by 2 plus 1, 2 get cancels, 3 plus 1, 4. That means for the system with the 3 unpaired electron, there must be a 4 ms value. So what will be the 4 ms value? Minus 3 by 2, minus 1 by 2, plus 1 by 2, and plus 3 by 2. Okay, these are the 4 ms values. Okay, let me write the energy level diagram. 1, 2, 3, 4. Okay, this is the ms value. Okay, plus or minus 1 by 2, and the ms is equal to plus or minus 3 by 2. Okay, all the 4 levels are degenerate initially. Now, because of zero field splitting, what happens? There will be a splitting of the ms level take place. Okay, here it will split like this. Okay, it will be splitting like this. Okay, this is ms is equal to plus or minus 1 by 2, and this is ms is equal to plus or minus 3 by 2. Okay, so here what happens if we apply the magnetic field? Okay, all this is happening in the absence of magnetic field only. Now if you apply the magnetic field, what happens? We will get how many lines? If for the system with the 3 unpaired electron, we should get how many lines? We should get 3 lines or 3 signal in the ESR spectra. Okay, what will be the 3 transition taking place here? So let me write in the absence of magnetic field. Okay, this is in the this is in the presence of magnetic field. This is happening in the absence of magnetic field. Okay, let me write here. Okay, or else I'll write here because I have no space here. So let me write here. So this is the level with the plus 3 by 2, and this like this. Okay, this is minus 3 by 2, this is minus 1 by 2, this is plus 1 by 2. So what will be the 3 transition? One is this, one is this, and another one is this. Okay, there are 3 transition happening for the system with the 3 unpaired electron. Okay, now we will see the system that is having the 4 unpaired electron. Okay, 4 unpaired electron. So for the system with 4 unpaired electron, what will be the S value? For first electron, S1 is equal to 1 by 2. For the second electron, 1 by 2. For the third electron, it is 1 by 2, and for the fourth electron, 1 by 2. Okay, so what will be the effective? Effective will be the sum of all the 4. Okay, half plus half 1, and it is 2, right? Half plus half and plus half, it is 2. So after writing yes, what is the next step? You should write ms value. Okay, ms value is minus es2 plus es. That means minus 2 plus 2. So what will be the values? We have 5 values, right? Minus 2, minus 1, 0, plus 1, plus 2. So we have 5 ms value for this one. Okay, let me write the energy level diagram. So I write the 5 lines. Okay, this is indicating all the 5 ms levels are degenerate, and because of zero field splitting, it will split like this. Okay, this is ms is equal to 0, this is ms is equal to plus or minus 1, this is ms is equal to plus or minus 2. Okay, so you can write what happens in the absence of in the presence of magnetic field. Okay, how many transition we should get? We should get 4 transition. Okay, how many unpaired electron are there? No, to that many extent we get transition. Now for the system with the 5 unpaired electron. For the system with the 5 unpaired electron, what will be the S value? S value is 5 by 2. Okay, just do the same like this only. For the first electron half, second electron half, for the third electron half, for the fourth electron half, and for the fifth electron is half. If you add them, you will get 5 by 2. And after that, ms value, that will be from minus s to plus s. That means minus 5 by 2, minus 3 by 2, minus 1 by 2, plus 1 by 2, plus 1 by 2, and after that plus 3 by 2, plus 5 by 2. So how many are there? 1, 2, 3, 4, 5, 6. Okay, there are 6 ms values are there. So initially it will be degenerate. Okay, it is ms is equal to plus or minus 1 by 2, plus or minus 3 by 2, plus or minus 5 by 2. All are having same energy initially, and because of zero field splitting, what happened? The ms level will split further like this. Okay, this is ms is equal to plus or minus 1 by 2. This is ms is equal to plus or minus 3 by 2. This is ms is equal to plus or minus 5 by 2. Plus or minus 5 by 2. Okay, this is because of zero field splitting. Now, if you observe the energy level diagram that we have written for the different systems having different unpaired electrons, okay, what you observe is that if the system is having odd number of unpaired electron, okay, if the system is having odd number of unpaired electron, what did you expect, or what did you observe here? Now here, this is odd, correct? 5 unpaired electron means you observed the energy level diagram something like this. And if you observe the another energy level diagram here, 3 unpaired electron, the energy level diagram is observed like this. Okay, now what you can write is that if the system is having odd number of unpaired electron, then you can see that ms levels are doubly degenerate, correct, right? So here because of zero phase splitting, all the ms levels are doubly degenerate. Now if you see the system with the even number of unpaired electron, here for example, if you consider this one system with a 4 unpaired electron, how is the energy level diagram? It is not doubly degenerate, while these two are doubly degenerate, correct? If you see the system with the 2 unpaired electron also, it is one is ms is equal to 0, another one is plus or minus 1. That means it is one of the level is not doubly degenerate. But if you consider the system with the odd number of unpaired electron, each ms level remains doubly degenerate. Okay, that is why it is called as Kramer's degeneracy or Kramer's doublet. Okay, this is called as Kramer's Kramer's doublet. Okay, these doublets are called as what? Kramer's doublet. Okay, this is seen only if the system is having odd number of unpaired electron. Okay, if the system is having odd number of unpaired electron, then each ms levels are doubly degenerate, and these doublets are there, no, that is called as Kramer's doublets. Okay, or this degeneracy is said to be Kramer's degeneracy. Okay, now one more thing I forgot to mention, why ms level splits in the absence of magnetic field. Okay, this is the splitting of ms level. No, why that the splitting of ms level take place in the absence of magnetic field? That is mainly because of interaction of unpaired electrons. Okay, zero field splitting is mainly because of what? It is because of dipole-dipole interaction. Dipole-dipole interaction of unpaired electron present in a system. Okay, unpaired electron present in the system. System means what? It is nothing but molecules. Okay, present in a system. Okay, why zero field splitting occurs? That is mainly because of whenever the system is having more than one unpaired electron, between those unpaired electrons there may be some kind of interaction. Because of that particular interaction, there will be a splitting of ms level take place in the absence of magnetic field. Okay, that is what we are observing in the system containing more than two unpaired electrons, and that is what we call zero field splitting. Okay, and one more thing, you need to remember what is Kramer's doublets. Okay, Kramer's doublet is a doublet, how can you define a Kramer's doublet? If the system is having odd number of unpaired electron, then each ms level will remain doubly degenerate, and that is what we call Kramer's degeneracy or Kramer's doublets. Okay, this is about zero field splitting or and Kramer's doublets or degeneracy. If you have any doubt in this concept, please let me know in the comment section. Okay, it is very important and very easy if you understand. Okay, feel free to ask in the comment section. Thank you for watching.